One of the cute things we're going to do for the power supply is we're going to do some auto ranging. And I checked this out. My initial plan was a 19 volt Zener, but the 18 volt seems to kick over closer to the 20 volt threshold better than the 19. So what's going on here? Well, it's a very basic circuit, and it better work. It works on the bench, but things go to hell pretty fast sometimes in electronics. So what's going on here? Well, it's very basic. We have our input voltage. Let's scoot the transformer over a little bit here. We have our input voltage from the power supply, and it's going through this divider network that's going to feed the DMM module. And we did some math, and we've got our we did our division ratio, so that's already been worked out. But the input voltage is coming in. It gets divided down for 20 volts to 200 millivolts is full scale for the DMM module in this range. So as we get closer to 20 volts, the breakover voltage for the Zener gets very close, and as soon as we get over about 19 volts, we have 0.7 volts at the transistor junction, and it causes the transistor to turn on and to close the relay, which causes us to go to the next range, which is very nice. And we're also going to gang that to the decimal point on the meter, so you're in the 19.99 range up until 20 volts. And then as soon as 20 volts comes along, the relay engages and it converts the range over to the 199 range. So 18 volts will look like 18.00 and 20 volts will look like 20.0. So you only get the one digit. These panel meters only give you 200 millivolts or 1999 counts. After that, it's overflow. So we're limited to 1999. So that's why this is 200 millivolts max. So when this engages, this is then dividing 200 volts down to 200 millivolts full scale. Of course, most of you guys already know all that stuff. But this is full design so that you can copy this. Go ahead and copy this wherever you like. It doesn't matter. This is very basic stuff here. And hopefully you can add auto ranging to your circuit or your bench meter. This is fun stuff. This is neat when the electronics looks like it's thinking. And ideally we would have a 9 volt supply, but I'm wound for 11 volts here, so our source is going to be 11 volts. If we were at 9 volts, then we could easily forego the 12 volt regulator. Now you can still forego a 12 volt regulator, you just have to have a resistor in here. So the resistor, you would calculate the resistor for this relay. It's a very small relay. We're probably looking at 20 milliamps. So we may forego the voltage regulator in favor of like a 300 ohm resistor or whatever. I didn't calculate that out. But you'll need some voltage source here to power the relay. And then you'll need also a 9 volt source. I believe these meters are 9 volt. I don't believe they're 5 volt. They might be 5 volt. I have to look at them. I haven't bothered to look at them yet. But these are the LED ones, not the LCD ones. I believe the LCD ones are 5 volt. But the LED ones are power hungry. So you'll need, you want to make sure that that's probably voltage regulated, just so that you don't burn out the LEDs and the meter module chip itself. this ground needs to be connected to this ground or it won't work. So those have to be common grounds. This is very basic, but you have to be able to build it. This is just your NTE 128 or 2218, something like that. 2219, 2218, whatever. Just general purpose transistor that'll handle 100 milliamps. Not a big one, just a little transistor. This is a small relay. So this is our single. It's a two-range circuit. You've got the range that it's in when the relay is normally closed, and then you've got the range where it's activated. Very basic. I just hope it works. It does work on the bench, but I'm just showing something basic here. Okay, so we're going to put that in the power supply.